Hello everyone. This is about a little program, a little application I've written. It's to do with this. See if I can get that in shot. There we go. Yeah, this ESP01. Actually, it's damn, what is it? Get to it. Ooh, where are we? There we go. Yeah, it's actually an ESP8266-01, which is the smaller version of this, what we usually get. It's like a mini. It's only got two. It's got two I/O pins. Let's have a look. See if we can turn that over. See if we can get that in shot and focused. Can I? There we go. Yeah. So it's actually it's got the UART, which we've got the TX, RX and TX. And then it's also got two I/O pins, general GPIOs, which is pin 0 and pin 2. They're important for me later on, right? But normally what we can do with these is, well, the Wi-Fi, and we connect to them using Wi-Fi. And you can use them two pins to control something. You can maybe switch something on and off, or maybe send a signal down to maybe, I don't know, do some intelligent LEDs or something, send a signal, and so you can remotely control some of those fancy LEDs. But what I want to do is really is turn it into like a go-between. Go between Wi-Fi and UART. I've got a project in mind, actually. Right, so let me try and explain. So, right, let's just focus again onto what we've got there. Right, so basically, right, we all know about these Bluetooth devices. So we can connect one of these Bluetooth devices to these Bluetooth to the UART on an Arduino, say, so we connect it to the RX and TX pins of the an Arduino, and then we've got communication through Bluetooth. Well, basically what I want to do is the same with this. I want to just connect this using the UART to, say, like an Arduino, or one of my favourite little tiny chips, one of these STM 8S103s. There we go. I got it out eventually. So I can connect this to the UART, and it turns this to a Wi-Fi chip, and then same goes for this. The what's this? STM32. Hang on, let's zoom in. Yeah, STM32. So if we stick this little thing onto the UART, we can turn that into a Wi-Fi chip as well, and control things via Wi-Fi and connect to it via Wi-Fi. So I hope you understood that. It's pretty basic. So what I used to do, program them was with one of these. You just stick it in like that, and that gives you so 5 to 3 volts. So you could put 5 volts in there, and I would have used something like one of these USB to UART converters. I would have sort of wired it up something like that, so we can program it. But what I've found, what I've got now, let me just get that back together before I lose it. Have I stuck that the right way? hang on. Ground 5 volt. There we go. That's it. Right. That's for what I use for. I've done a video I use for programming my USBs. Right. So let's just get rid of all that stuff. I don't need it. Just give me a minute. Clear the bench, so to speak. Yes. Oh, yeah. Right. I'll get rid of that one as well. Yeah, I found these. One of these. Let's zoom in on that. Has that got that? Oh, that's why I've got my other glasses on. Yeah, there we go. Ah, that's better. Yeah, one of these. So this is a UART, and it's got the UART already on it, and well, the USB to UART, shall I say? That's this chip. It's all this does. Chip is just converts USB to UART, so it talks to the TX and RX pins, and you stick it on. Stick it on like that, and then you can program it through the UART, and then you can also communicate through the UART as well from the USB. So I'm going to have this one and this one here. Let's just zoom on that one. Yeah, you can see I've got 2 pins on there. That's because when I was using this, I couldn't get to the 2 I/O pins, so I just soldered something on top. The other good thing about this one is it also breaks the pin. Hang on, let's get zooming in. Let's get focus. I mean, yeah, with this one, all these 8 pins are also broken out here, so you can actually connect these pins while it's plugged in. So that's another good thing about it, and you've got a reset button as well. So yeah, very good. So I'm going to plug that in anyways. Yeah, and so to demonstrate this, what I'm going to do is I've connected it to one of these, because you can actually talk to one of these through UART. And this is just a microcontroller, so basically what I'm doing is I'm just connecting this to the UART for this microcontroller on here. Let's tilt that a bit so the light doesn't shine on it. And these are the new things that control servers, so we can actually, just to give you some visual representation of me sending signals through this to this. So all I have here is a servo connected to that. I have this connected via the. I've got a wire on here. I did another video explaining why I put a wire here. This is 3 volts, 3.3 volts coming out, and so this is powered by 3.3 volts. Well, hang on, let me just get a bigger picture. I think if we look at one of my instructables, yeah, this one. I did an instructable here, Tim's mechanical spider leg. I mean, I just did this leg to demonstrate how to use this module, basically. So what we've got is we've got this module, and I can zoom in on that there, so we can see it now. So you've got your power in, so you can have 5 to 12 volts coming in here. I'm going to have, well, this black is ground and the red is V+, which is the same as this pin here, V+. So all I've got here is my power coming in, 5 volts. Let's just move that there, so you can see I've just got my power, my power there coming in. There's nothing else connected, not this. What the hell's that? Right, get that out of the way. Yeah, so I've got my power coming in, and then what we have on the board is we have here is a voltage regulator. and this drops the power on this this rail down to 3.3 volts, and so I can tap off this diode one here with 3.3 volts, and this powers through this diode, it powers this DVCC, which is the power for the microcontroller. So if we don't connect anything to this pin, we only have the V++. It comes in at 5 volts, goes through this voltage regulator, and it powers the chip at 3.3 volts, which means that now our GPIO pins, especially our RX and our TX pins, we're now at 3.3 volts logic here as well. So because we're powering it with 3.3 volts, we've got logic at 3.3 volts, which means I can use this, which is 3.3 volts, and I can send the logic through okay without a logic converter. Don't connect this setup with 5 volts. Don't put 5 volts on this pin here. If you've got one of these 3.3 volt microcontrollers connected, you'll fry your pins. So basically, we've come from 5 volts down to 3.3 volts, and we're running at 3.3 volts for the system, but the pins, because we've got 5 volts on this red rail here, the servos have 5 volts for the motor. The signal to the servo on the yellow lead is still 3.3 volts, but it's enough to send a signal, and these little tiny servos can take a signal of 3.3 logic. So we're good there. So basically, everything. Whereas the only thing we're connected by is power, no USB or anything like that. It's just power and our Wi-Fi. So let's go to what I've made. So as I say, it's got 2 pins on these little microcontroller, the ESP8266-01, and you can use them for anything. Now I've got a project coming up, and it has an old Bluetooth device connected to it. Now let me just bring back that Bluetooth device. Where did I throw it? Throw it in here. Oh, here we go. Right. So, yeah. So you remember. So these Bluetooth devices, you'll have come across them. We've only got the 4 pins on, which means that these only have the power, ground and VCC. Well, ground and power, not VCC, because it goes through a regulator to drop it down to 3.3 volts. So be careful when you're connecting these. So the TX and RX pins are only 3.3 volts. But basically all we've got is the 2 pins, the RX and TX. The project I am going to try and convert from Bluetooth to Wi-Fi has hardware handshaking. Now then, so how does that work? Let me see. I need someone to remind me, because no, not that. I don't want that. That's my ultrasonic thing. This one. Right, yeah. So I've written some code. Hang on, what's about that? I've written some code for this to turn it into basically the same job that this Bluetooth does. So we've got Wi-Fi in and UART out, and if we put UART in, we get Wi-Fi out. But I also want to use the 2 pins for hardware handshaking, which is so it's going to have RTS and CTS, which is request to send, and then we've got clear to send. So basically, when you're connecting one of the well, when you're communicating through UART, you can have 2 extra pins. So you can have 4 pins. So 4 pins basically. You have the RX and TX, and you have RTS and CTS. So you need the 2 more pins, and the way it works is, let me just go where I've configured it so I can remember. I'll tell you, my memory is crap. Yeah, so you can see one's in an input, so they're ready to send. Oh, sorry, one's an output. Ready to send is an output. So what you can do is you can pull this pin low to tell the device you're connected to that you're ready to send. And you also have an input, so you can see if the thing you're connected to is ready to receive. So if this is come out, it's clear to send. So what happens is, when you have some data that you want to send over the serial, the UART, what you do is you pull this pin low and you tell the device that you're connected to that you're ready to send data. And then the device looks to see if this input pin is low, to see if it's clear to send, because the device will see this pin pulled low and it will know that something needs to send something to it. So what it'll do is it'll get itself ready and then pull this pin low, so we can see that the device has pulled this pin low to tell it, our little thing here, that it's clear to send, and then we can send the data, and that's what we do, we send the data. So that's using the 2 hard handshaking pins. I can show this. What can I do? Well, yeah. So let's say if I was using my serial monitor to send stuff, you've got your flow control here. So you can have no flow control, or you can have X on and X off, or ready to send on and off. So you've got like these choices. This is all hardware basically. If you're doing it through software, then you don't have any flow control. It's just done by the microcontrollers. Anyway, so I hope I explained that okay. Let's get back to our little thing here. So I've programmed this, and what I've done is I've made another application, and this is what it looks like. Let's put it over here. There, we can see it now. Oh, all right. Yeah. So I've right. I've made these so they have a fixed IP address. Also in the software. Oh, my little application. If you want the code for this as well, I'll put a link to my application. And all you do is you click on this picture, and it'll bring some information up. Gives you a little bit of information about this. And I've also put a tab there with the Arduino code, so you can actually just press Control A to select all, and then Control C to copy it into the buffer, and then paste it into a text document. And if you call the text document this, and give it the uno suffix, and place it in a folder with the same name as this, basically. You can use Arduino to program this little thing. Right, so yeah, I've got that. Now, there was I've forgotten something, haven't I? Let me just put that in that top right corner. I went to this for some reason. I can't remember why. My memory, so bad. It's so bad. No, I've totally forgot what I was saying. Let's move on. Right. Okay. So I'll bring this back. So in this instructable, I went on to show how these work, and so that we can connect these via the RxD and the TXD pins here, basically. And that's what we've done. We've connected our thing to it. So let's just scroll down to that part. We don't need to know anything about the legs here. We just want to get down to the servo control. So I made an application also for controlling servos on that, really. You might be interested in. It gives a bit of information, which actually what we need is this. So we've got the UART. So to send a command via UART, say we want to change position here. I can't remember. Change position of the servo. There's no reply, but actually we can do a test. So what we'll do is we'll do this test here. We can send a query, and we should get a reply of 250 or 250 and 255. But when we actually send the servo figures, we don't get a reply. This is so that there's no traffic delay when you're controlling servers, basically. So what we do is we send a header byte, the address byte. This will be 0 because I've put the servo on pin 0, and then the data here will be it's 2 bytes, and it's the position you want the servo. So for us it'll be between 0 and 180. And then we've got a footer byte, which is the same as this one, so we add that byte onto it as well. And that's all we need to do. So we'll come back to that. Yeah. So if we look at this pin, this here. So instead of using this USB UART, so basically what I've done here, I haven't connected this servo power. I haven't connected this power. Actually, that's. Oh yeah, sorry. Yeah, servo power. So you got your V plus there, and it's also along this red line. But then we've got the microcontroller power, which is the DVCC. I've got nothing connected to that. Have I? Yes, I have. Oh, I've connected this USB UART here. But in mine, I'm using the 3.3 volts, so I've got nothing connected to that. And then we just connect the UART on them 2 pins there, basically. So that's what I've got here. Try to explain. Just see it better in the picture. Yeah, I've done some diagrams just to show you how to connect all that together. And if we just move down to some code. I could have used that picture there. Is that better? That's the same one. Yes, if we move down, yes, so we can see one of these. That's our UART one. Same picture, and our code. So you can see for the UART, what we do here, we send the header. So we serial write the header, which is, like I say, that 250 or in hex, which is FA, and then we send the address, which always not. Oh right, hang on, I got it wrong earlier. So the address is always not on UART. In I2C, there's actually an address to tell which I2C thing to go to. So we've got the address, which is 0, and then we've got the servo number, which is 0, and then we've got the position of the servo, which we can have. Well, it can be anything between 0 and 255, but the servo usually only works between 0 and 180. It's in degrees, is this, and then we've got a footer to finish there. So shall we do that? Let's do that. Shall I bring that up? No, I'll move that out of the way. Right, yes, so here's my little application for communicating with this. So we put the IP address in there, and now then I think let me just check that I've got the right one there. I've got two of these. What I've done is I don't know if you can see that, but can I catch it in the light? There, it's in black on black, but I've written 254 on back there. 154, shall I say? Yeah, can you see that? I don't know. 154. Anyway, there's 154 written on the back, so that's because I made it a fixed address. Then I know that it's 154 here, basically. Because it's on a local network, it's always going to be 192.168 and 0, and it's just this 154 that changes what we can set on a local network. I'll run through the code in a little bit. I'm sorry if I'm waffling on a bit, but anyways, so we connect. Have I got that turned on? No, I haven't got it turned on. I better turn it on first. One little tip with these. Hang about, let me just. Can you? Oh, let's have a look. Let me turn it on and off again. We should see a little blue light, and it should blink a few times, and then it'll give it a big blink, and that means we've connected, basically. That's connected to my network. So you can see there that we've now got connected. It's in green. And this window just shows anything received going this way, going out from the microcontroller. So to test that, we can't use ASCII. I'll do this one with the other one. But what I want to do is we want to send bytes, because what we're doing at the moment is this. What we need to do is that we need to send 250 0 and then we want to send the position, and then we want to send the end footer 254. So let's do that. So what I can do is I've done bytes, and you can see there. Oh right, actually what I've got in there at the moment is this one. Can you see there? So we've got 250, we've got 0, 255, 255. And 254. To send actual bytes, what we need to do here is you just separate them by a comma, each byte that you want to send. And we're also going to send a new line and carriage return after we send that as well. So if I send that, that basically is a query to get a reply. So that just checks that we're connected to this board. So let's send that. And it calls me a friggin'. Oh, hang on. Oh, hang on. It got disconnected. There we go. Right, yes. So I must have been messing around with it. Right. So yeah, we got disconnected. So basically, what it's done is it's replied with them two things. And if I now, because the communication is through characters, so characters in the ASCII table, if I didn't have this ticked and I sent, it comes back with question marks because it doesn't know what those values represent. So it doesn't know the. Let's have a look at an ASCII table. Let's do the full works. There's always something that I've forgotten to get ready in there. Yeah. So let's look at an ASCII table. So these are the replies we're getting. We see the decimal, or we can get it in hex. So the replies that we're getting, let's make that small, move that down. The replies we're getting is 250 and 255. If we look at what the ASCII value is, well, it goes beyond our 127, so it's out of range of the ASCII table, so it can't send one of these characters. It doesn't know what they are. So what we can do is we can click that to receive it as bytes. So when we send, it actually returns as bytes, so we can actually see the value of the byte returned. If I want it converted to hex, I can just convert it to hex, and then we can have it returned as hex as well. Anyways, so that's that bit. Let's get do one of these here. So like I say, if we look down at this command here, to actually move the server, we want the 250, which it always starts with a header 250. Address will always be 0, and then we want the servo number, so let's change that there to 0. And then we want the, so what have we got? Oh no, it's that one there. 0. Address 0. Yeah, so we've got the address, server number 0, and then we want position. So let's go 90 there. Okay, so I can move that out of the way. That was just following these numbers here. There, look, that one and that one and that one, and so on. Okay, let's move that out of the way, and let's just have a look at our thing here. We're not going to receive anything, so clear that. That's just going to stay blank because this doesn't send anything back once we've sent a command. Let's send a command, and we can see that it's moved to 0. It's moved to 90, sorry. So let's move it back to 0. Change that to 0. And let's try 180 and send that. And there we go. So you can see I'm communicating via Wi-Fi. See, the application is on my PC. My PC is connected to my local network, and this is also connected to my local network. And so, where's my app gone? So my app can communicate to this, which is on this address, and it does the it talk to each other. Right, so let's go back to 0, go back to 90. Yeah, so the reason I'm using this is so we've got like a physical representation of communication. What we can do now is, what I'll do is the other one, which is on, let's DC from here, the other one, right, which is on 155, and we connect, is actually connected to to right. Hang on, I'll unplug it. Let's just do DC. So this one is connected to the USB on my computer on COM port 10. Okay, so if I'll plug it back in, and I will connect again, And what we'll do is, if we look at our tools, where are we? There. You can see that I've connected on COM port 10 here. And so if we open up our serial monitor here, and I've connected, and what we can do is we can go onto ASCII and I can send hello. So let's try that. And we can see here on our serial monitor, which has come back from the other one plugged in via USB, hello. And if I want to type here, hi, you, and send that, we can see that it replies back here. So let's send hello again. And so I'll tell you what, let's put here, I am fine, and send that. There we go. And here, send that back. There, so you can see that I am actually communicating as you would like the normal. Let's go back to this. So I had this one which was connecting using the I could connect and send bytes this way by just separating each byte by a comma, and this one you can just type text in. Any text you send, type in, just goes that way. I hope you like this little application, and like I say, you just press this little picture here and this brings up all the code information. Well, there's About tab, and then there's the Arduino code tab, and then all this code. Oh yes, that's reminded me. Right, so let's go through the code, shall we? And like I say, this is the code, but as our excuse me, I'm going to cough. As any regulars will know that I prefer to use Visual Studio. Let's just close that. I don't want to mistakenly open that and allow people to log on to my network. The only difference between right, so when we click on this picture and we look at the code, you will see that this is not in this code here. That's because in this code you have this. Oh, hang on, where are we? Disappeared. There. You have this, and in here, this bit. So let's go back to here. You can see that I've got it commented out here. So if I uncomment that, there you can see this is where you need to put your local network name. You need to put your local network name in there, and you need to put your local network password in here. The reason I have this commented out is because these two variables have been defined in my credentials header here. And the way I put it in a separate header so I don't mistakenly show the world what my local network name is and my password to connect to it. So anyways, yeah, so that's so yours looks like this. Basically you need to fill in them two there. Need to fill in that, and you need to fill in that. So let's continue with the go through the code. Right, so I've also put in here a host name. This is supposed to, when you look up IP, if you use a tool to look up your IP addresses, if you've got a tool that actually shows the name of the devices connected, whatever's in here, that will be displayed. What I've done is I've called it Tim's, because it's mine. Let's just clear the board again. Yeah, I've just messed that up. Right, yeah. So this belongs to me, so it's my ESP1. So that's why I've called it Tim's ESP8266-01. Now the 154 that I've attached to the end of the name is the IP address I've given it. Now there are two ways to connect. I suggest you where is it? There. No, not there. Where have I stuck it? Oh yes, here. Sorry, Wi-Fi, under Wi-Fi. Right. So I didn't do that. Damn. Right. So what I have it set up with a fixed IP address. If you know how to allocate or reserve IP addresses on your router or hub or whatever, then uncomment this. If not, leave it commented out like so. And when you connect when it's like this, when you connect, your router or hub will allocate an IP address. But doing that, what you need to do is, let's bring Arduino up again. Well, we just need the COM there, so I'll just clear that. What I'll do is I'll just reset my device that's plugged into this COM port 10. Just resetting it. As it connects, it comes back with the IP address it has been allocated. So that's done automatically. Now also we've got the host name, and we've also got the MAC address. So it gives you details of its MAC address, which you can use to reserve an IP. The reason I've done this is because eventually one day I want to use these little devices to maybe go around the house and switch things on and off, and I want to be able to fix the IP addresses so then I don't have to keep sticking them into a USB port to find out what IP address has been allocated. So for the advanced people who want to define a fixed address for these little devices, just uncomment this, and it will use this information. Where are we? Yes, it will use this information when it sets up this. So it will configure it with the IP gateway and subnet mask and the DNS that you have provided it with. If not, if you have this commented out, like so, then it won't use this config here. You can see it's all greyed out, and it won't set these pins either, because oh no, sorry, that's another thing. No, I'll come back to that. Come back to that. No, this is greyed out, so it won't config with these. It won't config with this information here. What will happen is your home network router will decide an IP address, but in that case you need to do you need to find out what the IP address is through the USB. So I hope that's clear. Right, I think I've covered that. Right, let me just uncomment that. I need to do something while I remember, because I've given them fixed IP addresses. Right, okay, so pins 0 and 2. I've also made the software so you can actually have, as I mentioned before, hardware handshaking. So if you want to use hardware handshaking and use them 2 pins for the RTS and CTS, then uncomment this as well. So if you uncomment that, and that now the code will write itself for hardware's handshaking, and it will use these 2 pins for these 2 things. So it'll use it for pin 0 for request to send, and it'll use pin 2 for clear to send. And you can see down here that they're now they're not grayed out. So it will set them 2 pins if we have hardware handshaking enabled. So I'm not doing that at the moment. So that's for a project later on, and I'll probably show you how I do that when I do it. So at the moment, this is another thing why I use Visual Studio as well. You see, I've commented that out. Let's just save that. And if we go down to my code, we can see that these 2 pins there are no longer set for hardware handshaking. I can see in my code basically, and the same goes for this. So you can see that this is all grayed out because I'm not doing hardware handshaking. This is all grayed out as well. So there's this is for when there's no hardware handshaking, and I need a little extra code for hardware handshaking. I need to make it sure. So it only uses this bit when you actually upload to your microcontroller. Okay, right, I think I have covered it there. Yes. Right, yeah, so, well, I hope that was clear. So I hope you like my little application. Let's go to bytes again, and let's go to that. And let's try. Oh, actually, I'm on the wrong one, aren't I? DC. I want to go on to number 4, 154, and connect to that. And let's go 0. Oh, that's one. Let's go 180. And you can see how quick and easy it is. So basically, I've made this as a tool for when I'm actually creating other projects, that I can test what's happening here with this. It's just to actually connect to this and communicate and send data one way or another. So you can send it by bytes or send it by ASCII, one or the other. And like I said, because these are bytes, obviously the values that you put in here will be between 0 and 255. There we go, numbers. Yeah, I think that's it. That's all I wanted to show. Yeah, I think well, there's not much to it, basically. You just send in over the UART via Wi-Fi. Right, I'm going to stop rambling, guys. If you watched it to the end, thanks for watching all the way through. And usual thing. Any comments, just stick them in there. Right, I'm going to end it. Sorry. Right, where's the off button? Let me find the off button. Right, bye, guys.